Today we're going to talk about a new propositional connective, a truth functional connective that I'll call the biconditional. Now what's a biconditional? In order to explain what a biconditional, let me start off by telling you the following story. And this is a true story, I should add. When I was in 8th grade, I remember my first class in the morning was a math class. And there was a boy who sat next to me in math class. The teacher called him Bob. My third class, later in the morning, was a science class, and there was a boy who sat next to me in the science class, and the teacher called him George. And I was struck by the fact that Bob and George, who sat next to me in math and science class respectively, had the same last name, and they also bore an uncanny resemblance to each other. Well, one day, I asked Bob if he had a brother named George, and it turned out that he didn't have a brother named George. In fact, Bob was George. It was one and the same boy, and they just went by two different names to the two different teachers. But suppose that all you knew from my description of the situation was that there was a boy who sat next to me in math class named Bob, and a boy who sat next to me in science class named George, and you asked me one day, was Bob born in the United States? Now I might say to you, well, Bob was born in the United States if and only if George was. Now there I'm using the phrase if and only if. Now remember how the phrase if works. If I say if to connect two propositions, P if Q, that's equivalent to saying if Q then P. But now remember how only if works. If I say P only if Q, that's equivalent to saying if P then Q. So when I use the phrase if and only if, I'm conjoining the conditional if P then Q and the conditional if Q then P. And so I get what I'll call a biconditional. A biconditional is a propositional connective that connects two propositions into a larger proposition, and the larger proposition is true just in case the two propositions that are part of it have the same truth value. In other words, the larger proposition P if and only if Q is going to be true just in case P and Q are both true, or P and Q are both false. So, I could say George was born in the United States if and only if Bob was. Under what circumstances is that proposition going to be true? Well, it'll be true if George and Bob were both born in the United States, or, well, I guess it's misleading to say both, because really there's only one boy that we're talking about. If George was born in the United States and Bob was born in the United States, it'll be true when both of those propositions are true. But it'll also be true when George was not born in the United States and Bob was not born in the United States. In other words, it'll be true when both of those two propositions are false. What makes true the proposition George was born in the United States if and only if Bob was, is simply that the two propositions that are part of it, George was born in the United States and Bob was born in the United States, have the same truth value, whatever that truth value is, whether it's the truth value true or the truth value false. As long as those two propositions have the same truth value, it's going to be true that George was born in the United States if and only if Bob was, and so the biconditional connecting those two propositions, George was born in the U.S. and Bob was born in the U.S., that biconditional is going to be true. So we can state the truth table for the truth functional connective, which is the biconditional, as follows. The biconditional connects any two propositions, let's call them P and Q, doesn't matter what they are. When P is true and Q is true, then the biconditional P if and only if Q is going to be true. When P is true and Q is false, then the biconditional P if and only if Q is going to be false. When P is false and Q is true, then the biconditional P if and only if Q is going to be false. And finally, if P is false and Q is false, then the biconditional P if and only if Q is going to be true. So that's the truth table for the biconditional. Now, in the last couple of lectures, I described both the conditional and the biconditional as truth functional connectives, and I've given some reason to think that they are truth functional connectives. But you might worry that there's some